Hello and welcome to this video about equal and opposite forces. We're going to look at this rule today that says when two objects interact, they exert forces on each other that are equal in size and opposite in direction. By exert, they just mean when one pushes on the other one also pushes back on the other object. So exert is like push, but they tend to use that more complicated word. But when they apply, maybe is easy to understand, when they apply a force or push a force on each other, that force is equal in size and opposite in direction. And we often call these reaction forces. For example, when this person is sitting on the chair, the person is exerting a force downwards on the chair, and if you remember, we draw forces using arrows. But similarly, the chair is exerting a force upwards, which is equal in size and opposite in direction. So this time our two objects are the man and the chair, and they are exerting forces on each other that are equal in size and opposite in direction. That explains why the man is not falling through the chair. The chair is also pushing up and exerting a force on him as well. It also can help us to explain how things move. For example, if we choose the objects here, which are the boat and the water, when this boat moves, it has a propeller in the back, and that propeller exerts a force on the water. But to allow the boat to move, we've got this rule. If the boat is pushing on the water is also pushing back on the boat with a force that is equal in size and opposite in direction. When we're talking about equal in size, that's when we put a number to the arrows. Well, first of all, actually, the size of the arrows that we draw, if we draw them the same size, that tells us that they're equal in size. So here, those two forces would be the same size, whereas here, these two forces are different sizes. That one's smaller than that one. But we can also put numbers. For example, if this was 20 newtons to the left, a capital N for newtons, then there would be an equal in size force, 20 newtons, to the right. And similarly, if this man wanted to jump, when he jumps, he exerts a force downwards on the ground, but because of this rule as well, the two objects that we've got are the man, and if we were to put some ground in here, we can just call this the ground. Then when the man exerts a force on the ground will also exert a force which is equal in size and opposite in direction. That will then allow the man to jump upwards. So if we've got moving objects, for example, like jumping or the boat moving or a car moving, this rule helps us explain why, when there is a force going backwards or down, that an object actually moves forward or up, because we've got another force coming into play in the other direction pushing on the objects. So where these come to play in exam questions, they might ask you why an object is moving. For example, how does that boat move forward, for example? Or how do you jump to get the ball? And you need to get these 2 points in for your marks, that you've got a force acting on the object that is equal in size, first point, and opposite in direction. Now, of course, there can be a number of different forces acting on an object, and in the next video we're going to look at what we call a resultant force, so taking into account all those forces acting on an object at the same time. If you found this video useful, then please press the like button below and feel free to subscribe. Thanks for watching.